sind. I don't speak Turkish, so there are translators there. So if anyone needs a translator, then you can get it from the back. And I thank Cenk, the person that talked before me, for now finally telling what is the sequel of Avatar. And I learned it's Avatar, right? It's the Russian sequel. But we saw a lot of future technology. I'm going to try to stay a bit more back to reality. And the reality is already further than we have seen or that we see now in the market. So my role is I'm leading the healthcare market in Central Eastern Europe. I don't know who attended the talk of John this morning. Somebody attended the talk of John? Well, I sticked up my hand being a nerd, but I'm a healthcare nerd. So I've always been in healthcare. Since 15 years, I have a clinical background, but I'm always focused on IT. I have with me Matej Adam. He's the European healthcare leader. So if you need other conversations, and Peter Kuipers, who is responsible in Europe for healthcare alliances. So if some partners are sitting in the room, please approach my colleague Peter. John said already a lot of what I wanted to say at the beginning of my talk. And Isabel said it as well when she was opening. And the talk before showed it as well. The world is really changing. And I think we're going to see a Copernican shift in IT. And the way how we compute it is ending. And if you look at computing, and you can go from mainframe to mini computer to personal computer to smartphones, the way how we dealt with computers is that we always gave the information from the physical world to the computers. We were the interface. And even with the smartphone, we are the interface. And I think in the future, and what is going to change rapidly, is that humans are just going to be a node in the network. So in the old center, we were centrally around the data, and we were entering the data in the system. But I think in the future, we're just going to be a node in the whole network. And we're not going to have to enter that data into the system. The IT environment is going to be invisible around us, and we're just going to be one part of the system. I don't think it's going to go that far, that quick as I saw in the last movie, because it was a bit scary, even though I'm also kind of a Trekkie and love future science. But I think in healthcare, there's a huge potential there. If you look at IT adoption in healthcare, one thing that doctors really hate is interrupting their workflow to go on a keyboard and entering that information. They don't like entering information because it's documentation. It takes away their time. If you see what developments are focused on, the iPad is a huge success because it gives mobility, but it's still disrupting their workflow. And if you see what they're doing in operation theaters, they're now starting to use kinetic technology, so they don't have to use their hands to touch something. So it's like gestures can be the user interface. But at the end, everything we have to give that information to a computer, and this is going to change. This is going to change because we have seen before, I think, all the examples that we've seen on sensors that are really cheap. But we have published this, at the beginning of this year, we asked 5 of our researchers, which are your future predictions that will change over the next 5 years? I'm not talking about 2045 now. This is the next 5 years. And then what computers will be able to do is they will be able to add 5 senses to what they are doing. So they will be able to touch, they will be able to see, they will be able to hear, they will be able to taste, and they will be able to smell. And this is not far from now. If there was a journal, a study published now recently this month by the British Journal of Cancer, and they are working on nanomaterial-based tests for breath analysis. And now they have, out of the test, it's only 37 patients. 90% of the time, they could tell the difference between an early or a late stage of stomach cancer. So you start breathing out in a device, and you can tell if the person has cancer or not. And you can as well as tell if it's cancer or if it's just an ulcer. And this is going back to medicine, because the former doctors in Hippocrates, they smell to patients, and if he was a sour smell or what, then he would probably has a kidney problem, and smell was a part of the diagnostics, but we just eliminated that. But as said, like, if computers are able to see, to smell, imagine what we can do. Seeing, there are hospitals now using CCTV, and they're using CCTV and image analytics. And this is a bit disruptive for doctors, but what they actually do is that they analyze then, if there is an infection, they analyze all the images that had to do with that case, with that patient. They go back and they see where did the infection happen. So they can rechange their quality, they can change the process, or in that case, in that hospital, I know I talked once to the hospital director, and he says, like, I'm firing everybody who makes a mistake here, because I want to deliver top quality. And he said, nobody is, if he doesn't wash their hands and he's not compliant and he's just not, then I'm just going to do the analytics and use those tools and I'm just going to fire them. This is the only way I'm going to get 100% compliance. So the big eye watching can be used in that way, which is not that positive. But I think there are a lot of possibilities, and that we haven't seen today, that will happen at technologies we can use in hospitals or at home that are based on this new way of interface. So no keyboard anymore. It's the computer seeing things and detecting things. It will be pervasive. And I think we saw a lot of those examples before the quantified self movement, which was started in the US, in Silicon Valley. All the things unfortunately, I couldn't understand the presentation before, but I think he went through all of those. You see all these kind of sensor devices that start measuring. We had the Human Genome Project that really puts the human body into a DNA, and everybody has his own DNA. So there's a lot of data around the human, and the data is just exploding. And if you go back 5 years ago from now, then Salm Palmisano, who used to be our CEO, before Ginny Rometty took over 2 years ago, he started the Smarter Planet strategy. And I think it's fascinating because this was 5 years ago. And 5 years ago, he said, like, the world in a smarter planet is instrumented, interconnected, and intelligent. What does that mean? Well, the instrumented world, I think we saw it the last 45 minutes. There was everything what has to do with sensor data, the devices, the data that's being captured. That's the instrumented world. Interconnected, well, that's the social, the collaboration, the interconnectivity on the net. And intelligent is that what you do with all that data, that's the cognitive systems. 5 years ago, IBM was defining that strategy. And if you see now where we are now, then I think there were some very smart people defining that, because this is exactly what is happening on the market. And if you can see that how you can use that on hospitals, well, remote patient monitoring, a lot of hospitals in the US start sending these patients home with monitor devices. They're doing that remotely. So there are a lot of use cases that you can do and do things differently. The first talk after Isabel this morning from our Spanish colleague, or ex-colleague, ex-IBM, he talked about change. And he's like, well, it's not only about technology. If you really want to do that change, you have to start as well to change those processes, to change the culture. So he explained really well that everything what is here written as well, that is not only about technology. So smarter healthcare organizations are doing so because they are instrumented, interconnected, and intelligent. And if you look at an organization, well, we define a concept which we call smarter hospital, or you can call it digital hospital. What does it mean for a hospital? If you really would, and Turkey has the most, I think the most impressive transformation program from all healthcare ministries. If you look what the ministry is doing on the level of state hospitals, they're going to have 89 or 83 unions it's to make the hospitals which are owned by the Ministry of Health more autonomous. They're going to centralize it or decentralize it, and then as well they're going to build 75 new hospitals over 14 projects in a PPP model. I haven't seen any country in Eastern Europe or even in Western Europe that has such a program. And this is a huge chance for Turkey to really leapfrog to the next level. All Western European hospitals, they are challenged with an infrastructure that is 100 years old. Right? And even from just designing the building, even when you just have more windows in your hospital, you can reduce the infection rate by 10%, even just by designing it differently. If you look at the old hospitals in Europe, they are designed in a very inefficient way. Nurses walk 8 kilometers a day. Right? So just from the design of the hospital, you can do a lot. And then by using the technology, and so the digital hospital goes just beyond the clinical systems. It goes beyond what we have seen today in Turkey. If you look, I visited Acıbadem, I visited Medical Park, and I was in a lot of hospitals and visiting the Turkish hospitals. I was really impressed about, in the private hospital sector, I was really impressed about what they are doing and how what kind of services they offer. But it wasn't a digital hospital. They use a lot of technology, but it was not a fully paperless hospital as we call it. And if you look at the state hospitals, well, they have a lot of work to do still, but they are challenged with the budget, but this is going to change with this transformation program. So the digital hospital goes way beyond what we have now in Turkey. So it's not about the billing system, the health information system, but it's about integrating these applications with the medical world and with the physical infrastructure. That means that you can connect the building technologies with the applications and with the medical devices. And I will show you some examples of how we did that and what kind of an effect it has on efficiency. So it's a way to optimize your process. No, to build a digital hospital, you have to optimize your processes. You have to redesign it. And its technology is just a supporter and enabler. So if you want to build a new hospital and looking at this, well, you start using or talking to IT companies or an IBM or whatever company that is before you start building that hospital. You don't buy after the hospital is built some equipment, some fancy equipment, because you're not going to leverage the value of that IT that you bought. So going a bit like structured, so it's about integrating the information that is generated by the applications, by the research, by the medical devices, and integrating that with the smarter infrastructure, what we call on the building side, with intelligent building technologies, and then redesigning the processes. And our value proposition of IBM is that we say, like, well, we want to position us in the middle. We don't do health information systems. We don't do medical devices. We don't develop the smarter building equipment, but we integrate that. And we do that together with partners. But this is what we see and what we have done in other countries where we see our value proposition. And by doing so, you can really decrease your energy cost of the building. Hospitals are consuming most energy of all kind of industries. They're consuming double as much water, double as much electricity. And if you just think of what if you can have the operation room schedule connected to your building technologies, and you can just shut off water and heating when there's no patient plan, then you already do savings. And that's what we are doing, like connecting everything together. You can as well then, by using this technology, avoid readmissions, medical errors. There are a lot of medical errors, increased quality of care, and these are the usual value propositions. This is a project that we did together with a partner, and that partner wanted to develop and use this technology to say, what can we do to solve the issue that we have with the nurses? Turkey has it as well. Nurses are completely overstressed. They are documenting and coordinating 80% or 75% of their time. And 25% to 20% they are really doing the patient work. And then what you see then, and I think it's in Turkey not different, you see a high burnout rate. These nurses say, like, I studied a nurse to work on patients, and I'm a really bad paid administrator. So they just leave and they go in the private sector, because to be an administrator in the private sector, you just earn more money. And that's what you see in Turkey as well. I talk to a lot of managers, and they say, like, well, we are building a nursing school next to a hospital to be able to get the supply of those nurses assured. But we don't care if there's a high, we can't change the high fluctuation there. So, that's the customer here, that's UPMC in the US, had the same issue. It's like, what can we do now to change that? Well, you don't see a lot of technology, and that's what it exactly is. You have to make technology as invisible as possible. But what we did is we put sensor devices everywhere. So, and the nurse has a sensor device. So that room is smart, and so the building technologies are connected with the physical world is connected with the nurse, is connected with the applications. So exactly what I talked before about. So what she actually does is when she comes in that room, the screens know, or the computer behind it knows that that nurse is entering the room and that she is now with that patient. What it actually does then, it is a workflow system behind there that just then pushes information, tells her what she has to do. Normally the nurses have these work lists, and they have to go to that work list and go from room A to B and C. Well, she doesn't have anything with her. She just comes to that room and she sees exactly what she has to do, and she sees only that information that she needs to see at that moment. Because if you look at a laptop or an iPad, well, you have to log on, you have to look for the patient's name, you have to go check if he's allergies, and then you have to go on my work list. And so you have a lot of interactions there. So we don't have that here. So everything is pushed to the nurse. And you see here, there's a big touch screen. It looks like a giant iPhone. We did a lot of research, and it was like, that was the most efficient. Not the tablet, but just having it on the wall, because the nurse can move, and she has her both hands free, and she touches on the screen, and she and then gives in or enter that data. In a future stage, we're going to have the devices, the insulin pump connected, so she doesn't give it the values. The insulin pump will be smart, and the data from the insulin pump will directly go into the system, and the room will measure that that nurse installed that insulin pump with that value. So that's going to be optimized. So, and what we have seen is that we reduced, by doing so, we reduced the documentation effort by 57%. Just by using the technology. And this is tremendous. In one project, you reduce the documentation task, which only the documentation that was in the room, right? Not the whole documentation that she does, but the documentation that she needed to do in the room by 57%. They are walking now 1.8 kilometers less a day. I don't know if this is a good thing, but they walk less. They need less for documenting the ADLs. And for documenting the vital signs, they need 80% less time. So this is what technology can do nowadays. Of course, you need to invest more as a digital hospital or as a hospital, and you need a foundation for that. And I think Bulent Ekulo is going to talk about the medical grade network. Well, that's the foundation for doing so. You need a few basics to do that, but that's amazing. Technology can really start helping nurses to do what they love most, is working on patients. And the same thing will happen for doctors. So it's not going to disrupt their workflow anymore. It's not going to disrupt, or they're not going to have to do tasks which they are not educated for. So that's what this new technology can do in a hospital. Just shortly, one example. But all these systems have one thing in common. All these sensors have one thing in common. They create so much data. And, well, there's water everywhere. There's oil everywhere. But nobody is using that data. So this is a poet from England. And he said, like, water everywhere, but not any drop to drink. And that's exactly what I see with a lot of hospitals. They are sitting on data since 10 years, 20 or 15 years, and they don't do anything with it. They use it for operational performance measurement. Yeah. Well, that's the management side. But in the clinical space, there is so much to discover, and there's so much information available that we don't use. And this is one person from the NHS. He said that the application of what we know will have a bigger impact than any drug or technology likely to be introduced in the next decade. So he says, like, IT is going to have a bigger impact than what pharmacy did for healthcare. That's a statement. So in all that knowledge that is available, and I think also knowledge creation, in all that knowledge available, we're going to change the quality of care by using that information, by using that, some people call it the oil beneath the soil, that you just need to use it. And why do we need to use it? Well, in the US, 55% of the US receive the recommended care that they actually should need. They're like in the UK, an estimated 30 to 40% of care is not based on scientific evidence. And I think this is one of the reasons, that second one, why we are so challenged in the electronic health record discussion. Because a lot of these doctors, if they need to share that information to an electronic health record, this 30, 40% is going to be visible. And that's why they say, like, we don't want the electronic health record with patient privacy issues and whatever. But this is exactly the truth. A lot of these doctors are not working on the state of art, not on the latest available evidence. But I don't blame these doctors, because the evidence is like growing every 5 years, it's doubling. How can a doctor, with having patients in Switzerland, where I used to live in Zurich actually, so it's nice to be in this room called Zurich. But in Switzerland, the doctors have 7, and we all think Switzerland has high quality care. They have 7 minutes on an average to treat a patient. And they have to do all the administration next to it. They read each month 4 hours a month in literature. Well, with having 100,000 studies a year being published about diabetes, and if you are a diabetes specialist, how can you, with 4 hours a month, how can you be on top? You can't. So 1 out of 5 diagnoses is wrong. I don't say that it's connected to the last statement, but there's so much happening in knowledge creation, and for a doctor, it has been human impossible to take that knowledge and use that knowledge and bring it into practice. And this is like changing rapidly, and I think the model of a doctor, if you look, actually a doctor is like a big data repository. So he studies 7 years, he learns a lot, he takes all that data in his head, and then he sees a patient, takes that data, and he starts matching that data, builds a hypothesis, and does some, he then finds which diagnosis is the closest to where he thinks. Well, this is a big, as I said, like a data repository. The model is just like using and seeing all the IT now available. I think we have to change that model. And knowledge creation as well, if you see from the point of study design until the study or the results are implemented in the system, it takes 5 years to 7. So if we find new knowledge in the healthcare system, and until we implement it in the system, it takes 5 to 7 years. In the US or in the UK, let's say that in Africa or in other countries, it takes them 15 years to get there, right? And if you now saw the John's presentation and the other presentation, you see how rapidly Facebook, in 2 years' time, they had like 800 million users, or 3 years' time. But if you don't see this, well, this doesn't fit anymore. We need to change this. So we need to change the way how we create knowledge in healthcare. And I think, as I said before, the data that is available, there's a way how you can use it. And I will show you some examples. And I had the pleasure to be in Harvard Business School, and I was, one of my professors was Richard Boehmer, and he defined a healthcare organization, and this could be as well the smarter healthcare organization or the digital hospital, is an organization that simultaneously implement best practices for well-understood health issues, but at the same time creates new knowledge required to solve healthcare problems and embedded knowledge in the next generation clinical practice. So that means that this is a learning organization. So every time you do something, you measure it and you change it. Well, if you would do that without IT, that would be impossible. Right? And this is what we are doing, and I will show you an example how we capture that knowledge. So we have a product that is called, that was released last year. It's called Patient Care and Insights. And it's focusing on care coordination. Care coordination, I don't know if you're familiar with managed care models, integrated care models, where one person is responsible for the management of a patient. So in Turkey, I think in 2004, they implemented the family doctor system. And the family doctor is a kind of a gatekeeper for managing the health of these citizens. So what we see in Denmark, we did a project 10 years ago, where the primary care doctor is responsible for the coordination as well. So he's responsible for sending the diabetes patient to the pathologist, to the ophthalmologist, because all these stakeholders, they need to treat that patient, and they share that information. So the dietitian, the family as well, the caregivers, so everybody is connected in that treatment of that patient. But within that process, you can as well, as I said before, you need to treat based on evidence. So this is what I'm going to pick out of this slide. So one thing we have done is, or what we are doing is, well, if you have all that information of treatments available, how can we use that, and not scientific literature, but how can we use the data of the system to find best practices? So we mine the existing data out of the system. We then can do the modeling of the treatment plan, and then we can personalize it to the patient. So that's what I'm going to show you. So there's something called cohort analytics. People who studied statistics know cohort analytics, similarity analytics. So that means that by having 100,000 of patient records available, you can find patients which are similar. This has been done on the web. PatientslikeMe.com is a platform where patients do that with each other. So similarity analytics is you look in all these records, you find the patient that was similar to that patient, and then you try to define or predict the outcome if you would treat them the same way. So it's based on a patient's personalized profile to find the most similar patient. And it analyzes what happened with that patient, that cohort, and the reason why, and it predicts the probability of the desired outcome of the patient. So what we actually do is use all that data, which is available in the systems. And in Turkey, these systems have data, so you could be able to do that as well in a hospital system. And what you're going to do is to start predicting. You're going to start, if I select this treatment option, what is the prediction that this patient is going to die or have complications or heal? In short set. This is how it looks like. So this is the care flow. So you see like all the different paths that we had on that kind of disease. So this is chronic heart failure. And then you see all the different medications that patients took. And what it actually does for this patient, with the data that we have, this path is the one who is going to be the most successful. So these are all the paths that were defined, that were available. But the system tells, just based on this cohort analytics, well, if you're going to treat them with these steps of medication, you're going to have the best outcome. So this is not scientific research following statistical guidelines. This is using your system and what Richard Boehme said, creating a self-learning, evidence-based system or organization. And by using this information, I think academic hospitals are already using that, but they're doing everything manually. So the time, and now coming back to the time from 5 to 7 years, from knowledge discovery to impact. Well, if you have a system like this, it is in real time. You don't have to wait 7 years to discover knowledge out of your system and to implement in your system. So this is going to accelerate knowledge discovery extremely. And one of our Paul Grundy is our global director for healthcare transformation. And he said, like, well, in the next 10 years, the data and the ability to analyze the data is going to do for doctors' minds what X-ray medical images have done for their vision. And I think this is even an understatement. Sorry, the time is not out because he showed me just the time out thing, but I made up that I speak longer because the next speaker is not coming, right? So the next speaker is not coming, yeah. No, I have more than 5, but we said like 45 minutes. Sorry for that. But what we actually do with analytics is that most of the data in healthcare is available unstructured. It's images is unstructured, ultrasound is unstructured, and what you see, the IT systems, they're all structured. They're tables with columns and rows, and doctors need to fill in that in columns and structure their thinking, even if they think quite unstructured. That doesn't fit. So if we can use the unstructured information and start working with what means 80% of all information in healthcare is unstructured, we will be able to change this more rapidly. And Watson has been named. We have been doing that with Watson Technologies. So Watson was focusing on analyzing large volumes of unstructured and structured data, but most of it unstructured. It understands the natural language out of that, the context out of it, and it generates hypotheses. And this is exactly, if you look at Watson, what a doctor does. A doctor makes a hypothesis and he challenges that hypothesis does test, right? And it supports iterative dialogue to refine results, and it learns. So that's what John said this morning as well, right? So Watson is a learning system. Watson is now focusing on the US, and we have done first projects in the area of cancer, because cancer is that area which is the most complex to treat, right? And it's burden and it's generating a lot of cost. So what we actually did is that we put Watson on top of the electronic health record. So this is the electronic health record. This is what Watson pulls out of the electronic health record related to that case. So it just gives the information what the doctor needs, the same as with the nurse in the room. So it just gives that information which is relevant for the diagnosis. And if you go and it says like, okay, these are the key points, you can click in that and you drill down in that information. And then out of that information, it says like, well, I didn't find in the electronic health record pathology, an MRI. I think you should do that. So Watson advises the doctor to say like, okay, based not on rules, based on what he reads and what is available in the literature, Watson advises, and you can click then on the evidence, and you will see then why he advises that. So The same thing for the treatment selection. When the treatment is selected, he will say like, well, this kind of chemotherapy will probably have the best result. And this is based on 600,000 papers, this system. And it's self-learning, as I said before. Right? And if he clicks on evidence, then you can see what the references are. These are the NCCN guidelines. This is that study. So all the literature behind that. So we don't have to build it. We just put the literature in there, and Watson is analyzing that. And the more doctors use that system, well, the better the results will be. And we did that. We started with the Memorial Sloan Kettering, which is one of the top institutes for cancer treatment in the US. And we now, after 6 months, have a 100% liability. So Watson is doing the same what doctors are doing. But just imagine if you would have a system in a country like Kazakhstan or even Turkey, and you would make that knowledge available for everyone, for all doctors, not for the patients, for all doctors. You would increase quality of care instantly. But this is like all in English, and we don't focus on bringing it to other markets yet, I have to say that. But we can do things with that technology nowadays. Sequoia Hospital, they use their data to analyze what is the risk for a patient that has a heart valve replacement planned that is going to die. We use data from 100,000 or 10,000 patients, and then we define algorithms that predict the outcome of the heart valve replacement. Within 1 year, we reduced the mortality by 50%. And this for the hospital is important because these quality benchmarks are measured on readmissions and mortality. So you can do that nowadays. Another example, Seaton. Seaton is focusing also on heart surgery. And what they wanted to see, and I think Turkey is planning to implement DRG billing systems. And in DRG, you are punished when a patient is being readmitted. So if you send the patient home too soon, then, well, that's what you earn more money. But if he comes back into your hospital, you earn less money. So you get punished. So they want to see what is the risk if I send him home now that he's going to be readmitted. So that's the business challenge behind it. And actually what we saw is that when we digged into structured data, into unstructured data, that the unstructured data was there where we found the best information. Not in the structured information within the system, but the smoke, it was written in a text that he smoked. There was written in a text how he was living, and if he was living assisted or not. That is not in the EMR. That is not in the health information system. This is in plain text. This is valuable information. So all the information that we read was mostly, and that was valuable to predict the outcome, came out of the unstructured data. I was talking to the Minister of Health in Turkey a few months ago, and the person who is responsible for analytics, and he's like, we have everything structured in Turkey. And I said, like, forget that. Like, don't structure it, because now we have technologies to deal with unstructured data. And don't try to make doctors do everything structured. It doesn't work. So if you do that, if you give access to patient information, and you give access, like Watson is doing, to the clinical knowledge, so the more patient information you get from all these sensor devices, from everything what we get, and the more you can connect it to cohort analytics, to Watson, the more personalized your treatment will become. And treatments that get personalized, they will, at the end, if you see these 2 peaks, these are 2 peaks of uncertainty for a doctor. Once he does the diagnosis, and once he selects a treatment. If you give access to patient information and to clinical knowledge, you will shorten the time of treatment, and you will reduce these uncertainties. So what happens at the end, if you shorten time, reduce uncertainties, you have less complications, you have less cost, you have high quality. So at the end, if you really would invest in systems, but I think Turkey needs to have that in a more global approach, like in the whole country or in a region. I don't think a hospital in itself can do that. Then if you can do that, I think you can increase quality in 1 to 2 years incredibly. And then you will see these growth numbers, on like the Facebook numbers, that everything is going to go so quickly. You will see that happening in healthcare as well. So what is IBM doing shortly said? How can we help that? So what we do is we have technology that helps you to build, as I said, these foundations. We have the analytical tools and capabilities, and we do services and software and hardware around that. And what we did to be able to do so is IBM invested like 16 billion in buying companies that were doing that. So we bought all these kind of companies that were focusing on analytics, and everybody who was in university knows SPSS. these tools are the basis that we use. And with these tools, you can build also the cases that I said before. And we also focus on the open standards, which is super important. And I think Turkey is doing a good job there. Turkey is focusing on HL7. They're focusing on IHE. I think the IHE connectathon is in Turkey this year. So Turkey is really focusing on all these standards which we support. And we are a healthcare company. We have over 8,000 employees working in the healthcare sector. We have 60 medical doctors, or nearly 60, and 350 health professionals working. We are working on building up an ecosystem in Turkey. So we are working with partners and discussing a lot. We are advising at the moment, because it's these PPP projects, this is long-term planning. But we are really open to collaborate with other partners. And I think Turkey, as I said before, offers for us, with the dynamics here, there's a huge opportunity. In Western Europe, there is not that opportunity because there's so much politics, there's old buildings, old infrastructure. I think Turkey can leapfrog and reaching that goal to be a medical or a healthcare tourism hub, right? Turkey wants to position themselves as a place with higher level of quality so they can attract medical tourists. So a huge opportunity for everyone sitting in the room, hopefully. Teşekkürler, or teşekkür ederim. If there are any questions, then please go ahead. Yeah.
Are there any examples of Turkey now is using these healthcare systems?
Not in that sense that I said now. So these are high advanced systems. We have been talking, if you look at natural language processing, well, we are working with universities to work on the translation in Turkish. Because what you're going to do if you have a health record which is in Turkish language and you have literature which is in English literature. So we need to build up a roadmap, and we need to work with partners together to do that. This is something that you just buy on a CD and then install. This is work that we need to do together. But if you have ideas or if you have customers that you want to address that we can do that together, then I'm happy to talk to you later. So, any other questions? I will be here all day, and Peter and Matej will be here all day. So I don't know, but Matej has to fly away, I think. I think you will be here a few hours. Okay, then, teşekkürler. Have a nice day. Thank you.